Let's say you decide to plant a garden, and in that garden you want to have 4 equally spaced rows of 3 flowers. If you think in that way, you gotta go to the store, get yourself some seeds or some seedlings, or maybe you just get the whole plants yourself and not gonna do that much work and hire somebody to dig them up for you too, and it'll just be right there waiting for you. But point is, if you want to know how many flowers you need to get there, well, you'd have 4 rows of 3 each. So that'd be 12 of them, simple multiplication there. And then if you want to think about how much space that's going to take up, you want to know how big of a garden you're going to need to build, well, let's say that you need to give each flower 1 foot of width and 1 foot of depth or height, however you want to say that, thinking about it, looking down on your garden as if like you're on a ladder staring straight down at it. Well, if you think of it in that way, you can get a diagram, something like this, to represent what that whole picture would look like, where, because you've got each of those blocks that takes up a foot of space in both directions, and you have 12 of those blocks, you would say that that takes up 12 square feet, because each of those blocks is 1 square foot. And that's how we talk about areas in general, at least that's the way we visualize these things mathematically and geometrically, as of a lot of the work by people like Descartes in the 16th and 17th centuries and beyond there is in terms of rectangles and in particular squares. There are other ways that we can understand visual space and how these things work, and 2 dimensions obviously is very deeply flawed for the fact that we exist in at least 3, but it's the way that we see the world. We could change the way that this goes, and we could see about talking in other ways, but that's a very philosophical, very deep topic that it's a bit beyond the scope of this class. You go pretty far to think about those things. We're just talking about the basics here of finding these kinds of values, where when we're talking about areas, because we're talking in terms of rectangles, we're talking in terms of things with length and width, in particular squares where those length and width values are the same. So you can look at things like 1 square centimeter, obviously a little bit bigger than 1 centimeter with that picture there, or a square inch, or a square foot, or a square yard in terms of those pieces that we break apart into 3 feet for the yard, or 12 inches on a side for the foot, or whatever other different combinations that we have to work with here. That's how we discuss area, is in terms of those nice, perfect, in a sense, at the very least, convenient rectangles, the squares. And one thing we can use this for, one way that we can apply the idea of talking about areas, because we're not going to get into too much depth here in terms of actually computing areas of solids, that's more of a topic for a different class, is how we can bring these things into the context of units. First, talking about an idea called population density, which is how we figure out how many people are fitting into a given space.